Good afternoon. Hello, everyone. So welcome to the Tuesday afternoon of talks at EAMS. So afternoon here in the UK anyway. So we have 3 talks lined up for today this afternoon. So we've got Agnieszka Jack from the Hankett School of Economics in Finland talking to us about using Jupyter notebooks to support maths learning. Sally Jordan from the Open University talking about gendered differences in response to assessment tasks, and Colin MacDonald, Andrew Recknitzer talking about paperless open marking. So we've got three lightning talks, and we have our speakers here, so you'll have the opportunity to ask questions at the end of each talk. Just a reminder, please do send your questions through to the questions link on the Moodle site. We'll keep an eye on that, read out some talks at the end of each, read out some questions at the end of each talk, and that gives us the opportunity to keep the conversation going afterwards. So we're going to pass over now to our first recording from Agnieszka.
Economics. I teach mathematics and statistics, and I do research in time series analysis. I'm about to record my lightning talk for the assessment conference in Newcastle. I have to say that I almost got coerced into wearing a Sunderland t-shirt because my husband happens to be a Sunderland supporter. Let's take a look at my outline. The title of my talk is Using Jupyter Notebook with Python, Markdown, LaTeX to support maths learning. In my talk, I'm going to perform a Moodle quiz with questions that have Jupyter Notebook files. These files have extension IPyNB. They contain code chunks written in Python and text chunks, and these are written in Markdown. That also uses LaTeX syntax for typesetting math formulas. And these Jupyter Notebook files, they will contain examples with applications of mathematics and economics. Prerequisites for me as a student attempting this quiz is I need to have Anaconda, which is a Python distribution, installed, and I need to know how to open Jupyter Notebook files. My learning outcomes as a student are I'm able to, well, perform particular tasks related to math. And so this would be, for instance, I'm able to recognize a logistic function. I know how to calculate present value. I'm able to compute Taylor expansion in Python, etc. There are other learning outcomes as well, and these would be related to the software itself. So for instance, I'm able to use Jupyter, I can explore code and text chunks, I'm able to dissect those chunks, I'm able to interpret the syntax and also to modify it. So the idea behind this talk is to give you a taste of Jupyter, Python, Markdown, LaTeX. Most of you will be familiar with LaTeX. And then to give you a chance to see if you'd like to use these tools with your students. So now I'm going to start the quiz. So here's question 1. The question is of matching type. It starts by saying save and then open the attached file. So I'm going to right-click on this file and save it on my desktop. And then the instructions here say we'll open this file in Jupyter, so I'm going to start Jupyter. So I go to the bottom left corner of my Windows menu, and then I have here Anaconda. And after unfolding, I see this option, Jupyter Notebook, so I hit that. So I have a black window popping out. This is a window that with so-called kernel, which does the computations in the background. I'll minimize it. And here I have a dashboard of Jupyter, which opens in my default browser, which happens to be Firefox. So now I'm going to open my notebook file. So I navigate to desktop and I have this file limits and continuity. So here the instructions say double click on the top cell, which is of type Markdown, to view the Markdown syntax. I'm going to do that on the left-hand side, double click. And here I see the syntax for Markdown and also LaTeX syntax embedded within it, two types of mathematical formulas. Then I hit run to return to the output. So the idea is that I go over this file by going back and forth between the syntax and the output. And I choose the right options in the quiz question on the right-hand side. Okay, question 2 starts in the same way. So save and then open this file in Jupyter. So I save the link again on my desktop. And then go to Jupyter's file and then open. And here I have this present value. So this file is a little bit longer and it has text chunks at the top, but it also has so-called code chunks below. So now the instructions are go to kernel option of the menu and then hit restart and run all. So rerun all the chunks. You can see these asterisks. And then the idea is that I study these chunks which are related to calculating present value. There's a graph here, etc. And then I answer the questions in the quiz exercise. This happens to be multiple answers, so-called CLOZE, C-L-O-Z-E type in Moodle. Next exercise, number 3. I proceed in the same manner, so save on the desktop and then open in Jupyter. So now I have a logistic function. There's a story here about the logistic function and then the code. So again, I go to the kernels menu and go for restart and run all. So the idea is that I go through these chunks and then try to answer the questions on the right-hand side. This question type is, again, multiple answers. Finally, the last exercise, I save the corresponding notebook file and then open it in Jupyter. It's called Taylor, as you can imagine, it's related to computing Taylor series in Python. So I have a text chunk introducing the exercise and then some related computations in Python. So again, we go to kernel and restart and run all. And this exercise is not enough to explore the chunks and play with them. We have to actually modify them to get the answers here in this exercise. This exercise is of type matching. So now I can close all these notebook files. I go to File, Close and Hold, Leave Page. Do the same for all the files. Okay, so then to shut down the kernels that run the code behind these notebooks, I go to the black window. So here, and I hit Control-C twice. So that was the idea behind this talk. Thank you very much.
Okay, so Agnieszka hopefully joins us now. Can you hear me, Agnieszka? Yeah, there you are. Thank you. Okay, so participants, just a reminder, do pop some questions in the Moodle site there. So a couple from me, I guess. So this was an economics module, is that right, Agnieszka?
Mathematics for economics, yes.
Mathematics for economics, and so the motivation behind this, I guess, was to teach the students bit of Markdown, a bit of Python, maybe a bit of LaTeX as well. Is that right?
Yes.
Yeah.
Yes.
How does the quiz fit in with sort of other? Are you teaching these things before they take part in the quiz?
Yes. Yes, the materials incorporated into
And is this a sort of part of that module, or is the main learning outcomes of the module to sort of familiarize themselves with these sort of languages?
Yes, it's included in the learning outcomes too.
Yeah.
Yes.
Okay. Interesting. So a few questions from the Moodle site. So that was a comment. Recently saw a talk on generating version Jupyter Notebook exams. Could be great for this. So I'll leave you to take a look at that. So comment from Christopher Jobling. I use Jupyter Notebooks in a published form using Jupyter Books. Wonder if there's any scope for embedding quizzes inside Jupyter Notebooks. So I think there are some options for doing quizzes inside Jupyter Notebooks. Have you looked at those at all?
No, but I'm hoping for some at least partial automation of what I'm doing by linking a LaTeX package called Moodle with lowercase m, which allows one to typeset questions for Moodle in a text or LaTeX editor, and then you export an XML file. And then if that can be combined with another LaTeX package that uses Python and LaTeX to mix code and text chunks, then possibly combining these two tools would lead to some at least partial automation. But I'm not aware. I haven't checked any sort of notebook and LaTeX related tools available. So I'll check that tip from.
Nice. Okay, thank you. So we've talked quite a bit during the conference about the incentives for students to share answers and that sort of thing. So a question from Karen Henderson here. Do all the students get the same Python files and questions on them, or is there some randomness in the questions that you ask?
So at this point, I don't have it yet, but I'm hoping to come up with some sort of system that I just described roughly for some, to parameterize the input values at least to some extent.
Yeah, so that would open up some possibilities. That's great.
Yeah, at least.
Managed to navigate away from the questions.
I could just add that I managed to get a similar system working with R, a system meaning Moodle, LaTeX, and simulation, randomization, or data analysis in R. And this is more for statistics or sort of mathematical finance, quantitative analyses. And this would sort of be along the lines of what we saw done in GOES, I think, with SPSS and R. On Monday, I think there was a talk about that. And the randomization that I'm hoping to do with Python and Jupyter Notebook would be sort of similar to what Björn, I think, was doing with static randomization. I think he talked about it. Incidentally, he used Jupyter Notebook, but I don't suppose it's important what sort of environment you use for running Python.
Great. There's a couple more comments in the questions there. NB Grader, thank you, Colin and Debbie, was the tool in Python to create quizzes. So that might be worth checking out. So thank you again, and we'll move on to our second talk. Thank you, Agnes. So our second talk is by Sally Jordan, and I'll pass over to that recording now.
Hello everyone. I'm going to give a short introduction to a longer piece of work. I've had to cut a huge amount out to fit this into 10 minutes, and if you want to know more, the whole presentation is available on the Moodle website. However, I feel I can't fail but to acknowledge the work of both my collaborators, Holly and Hilary and Mark, and our funders, the Ogden Trust and Esteem. So what's this about? Well, basically, some groups of students do better than others. I'm focusing on physics. I'm focusing on the Open University in the UK. And I'm initially focusing on the difference between male students and female students, where of course gender isn't actually a binary division. What we're really trying to do is just get under the skin of what's going on so that we can improve the experience for everybody. Concentrating then on the gender gap, and indeed I'm actually concentrating on one particular module. It's a module with the code S217, its predecessor was S207, and it's our Physics Gateway module. And over time, men have been significantly and consistently both more likely to see that module out to the end and to pass it and to get a good pass. That effect isn't there on other modules, and in fact on some of our modules it's reversed. And that finding is actually quite common across the UK physics education sector, that effects vary from module to module. But coming back to this particular example, in fact, the effect is quite stark. So what we're looking there is the distribution of different outcomes by pass, that's pass 1, pass 2, pass 3, and pass 4, where pass 1 is distinction, for the entire population of male students, shown in blue, compared with the entire population of female students. As you can see, men are much likely to pass, they're much more likely to get a good pass than women are. There are a number of hypotheses for this sort of effect in assessment, and unfortunately I just haven't got the time to talk about them now. We have investigated the other effects, and it's a bit of a spoiler alert, but I'll say we haven't really found anything that explains the entire effect. And for the purposes of this talk, I'm going to concentrate on things that relate to assessment, that there may be something in our assessment that's actively favouring the male students. Again, when you look at assessment, there's all sorts of possible explanations for what might be causing a gender difference in response. I'm just going to pick out a couple of those. I think the idea of gendered context is quite interesting. That's the idea that maybe the way in which the question is worded, is it given in the context of a particular sport? Is it talking about guns, something like that, that might disadvantage particular groups? I don't think there's actually any hard evidence that supports that, but there is evidence that obviously, if somebody can't understand a question, then they can't answer it. So it's something that we need to be aware of. There's a fair few papers that talk about a disadvantage to women in the use of multiple choice questions, and that's what I'm going to be looking at in more detail in a minute. Other ideas are that there may be something in the presentation of the question, the number of words, whether it's got diagrams. There may be something about the length of the test, and it may depend on the amount of scaffolding that you put in. That's the number of hints. Now, we have looked at that as well, and if you're interested, I'd refer you to the paper by Dawkins there. And finally, of course, it may be what the question is assessing. So just homing in on this, whether it's multiple choice questions that are causing a particular male advantage. So here we have men are shown in blue. I'm afraid women are shown in pink. It's not my picture. And this shows an exam, a number of exams, which have part A, multiple choice questions, part B, short answer questions, and part C, longer questions. You can see that the median for men is higher in each three cases, but I hope you'll agree that there's not any significant difference in the gap between men and women for the three parts on the exam. That contrasts with this slide, which shows the difference for the different part C questions. And just to explain, students chose 3 of the 7 questions. And you'll see that, if you can manage to make out the different colours there, that sometimes men do better, sometimes women do better. And that becomes particularly interesting where you see that actually this is the difference in which of the questions men and women choose. And interestingly, question 20 and 21, which are the Newtonian mechanics questions, men are actually more likely to choose than women. Whereas it's actually the other way round for the other questions. So maybe there's something in that. So in an attempt to explore this multiple choice issue, we looked in more detail at our interactive computer mark questions, which refer to as ICMAs. And as I think probably most of you are aware, at the UK Open University, we now use Moodle. We did use OpenMark, and that was the system we were using when a lot of this work was done. However, the principles remain exactly the same, and the fundamental thing is that we're not just talking about multiple choice questions, we're talking about a very wide range of different computer mark question types, including some really quite sophisticated ones. And the whole range of question types was in use on this particular module. There's a total of 56 different ICMA questions represented in that slide, with the numbering along the horizontal axis and the mean score, which was out of 4 for each question, on the vertical axis. And you possibly can make out that the men, again shown in blue, tend to do better, well, more than tend, they do better on most questions, but not absolutely all questions. But most significantly, the amount of the difference and whether it's not significant varies. So just looking at 3 particular questions now. Now these are the 3 questions which, for a really quite large data set, we found that there was a significant male advantage. I'm going to show you the 3 questions. I'm not going to say much about them. I'm just going to show you what they look like. And point out that those 2 questions are both constructed question types, constructed response question types, where people are typing their answer. They're not multiple choice, they're not selected response questions of any type. And the third one that had a male advantage is the one shown on the left, which is a drag and drop question type. That's a thermodynamics question. The other 2 were mechanics. The only significant different thing between those questions that we've been able to identify is that they all have 2-dimensional or 3-dimensional diagrams or graphs, which actually not that many of the questions do. The interesting thing is that the question shown in the right, which actually has a slight female advantage, it's not significant, but it is an effect that's repeated quite a lot for different questions and on different modules, is actually a selected question type. It's a multiple response question, and women do better. So it's interesting. We haven't found that multiple choice effect that others have reported. I would comment that the questions, like the ones on the right there, actually are quite wordy questions. I just want to end by looking at this from a different piece of work, looking at the same thing. And the context for this is the force concept inventory, which some of you will be aware is a very well-known concept inventory used to assess conceptual understanding of Newtonian mechanics. And it's 2 significant points that I'd highlight. The first one is that it conventionally relies on multiple choice questions. And the second thing is that it's pretty well-known fact that men do better on average on it than women do, particularly on some questions. And if you put those 2 things together, you begin to have a piece of evidence that looks really to be quite contrasting to what I've been talking about a few minutes ago. Where we were able to get involved was a PhD student of ours, Mark, has actually developed a free text version of the FCI using Moodle's pattern match question type. And in development, the developmental version had roughly half free text questions where people were typing their answer as a sentence, and half were multiple choice questions. So, was there still a gender difference? Now, this is very early work and we don't have a huge data set. But from what we can see so far, there is still a gender gap, but it's not as big as it is for the purely multiple choice version, and the effect's larger and more significant for the questions that are multiple choice than for those that aren't. So we thought, well, this doesn't make sense at all. We've got evidence from different places that's saying different things. But then we realised that half of the multiple choice questions had been one of the reasons why we'd kept multiple choice questions was that they were the questions where people were maybe asked to describe the trajectory that something followed, which is quite difficult to do in free text. So we'd kept them with their diagrams, with their two-dimensional illustrations of a ball being thrown into the air or something like that. And was that maybe the explanation? Was it this diagram thing again? Unfortunately, the early results we've got indicate that that's not the explanation. I'm going to stop with that slide. This is clearly an area that still needs further work. We know that there's a problem, but we don't know what the problem is. We're continuing to work in the area. If you'd like to work with us, please do get in touch. Thank you very much.
Thank you very much, Sally, for that fascinating talk. It's really interesting. Got several questions. Can I ask you, first of all, Sally, how far back does this trend go? How long have you been looking at this data on?
Yeah, thanks very much, Chris. I would say that two things. The first, before I start, the first thing is apologies for the poor sound quality of that. I haven't got a headset on now, so it should be better. The other one is that in the audience, I also have Aaron Sturton, who's a new PhD student we've got starting with us in the autumn, who'll be working with us in this area. So to answer your question, a long time really, and I'm quite shocked by the length of time that it's taken us as a community to wake up to it. It's something I'm passionate about. Our data set, we were woken up to it by a particularly bad year, which was 2013, by which stage it had been around there for quite a lot, for quite a long time. I can see his question around data size, the size of the cohort. We have big cohorts. We have typically on that particular, some of our modules are thousands of students per module per year. This particular one is the order of 500, something like that. And this has gone on for years. There was one year we thought we'd fixed it, and the module team chair we haven't actually done anything different. The module team chair was sort of out celebrating, but it was just a glitch. So yeah, it's quite persistent, sadly.
Thank you. That's,
can I also just say that just picking up on some of the points that are coming in, it's an interesting one. There's some really good points coming in, but the other thing, the FCI, the Force Constant Inventory, of course, that's massive. I mean, the numbers using that across the world are huge, absolutely mind-blowingly huge. And this, again, this gender difference is definitely very much there. And I think what I find the most interesting is that it's not the same for all questions. And I think it's something that we have to be, all of us, it behoves all of us to be really careful.
Yeah, okay. So just picking a couple of questions out from the middle side there. So James Fodey asked if you have looked at correlating the gender of the teacher creating the questions with the gender gap.
It's a really good question, James. We've done a weeny bit of work in that area. We've looked at the we operate because we're a distance teaching university. We have our associate lecturers who are the people out in the field, and we have done some work looking at whether there's a correlation of effect between the gender of the person that's providing that support. That's a direction on that. There is another one which does stem back to that essentially bias that you're putting in when you're writing a question, and I'm not terribly familiar with it, but certainly it's a direction we are moving in. In our equality response at the OU is looking to run essentially unconscious bias workshops, but not the normal sorts of unconscious bias workshops, ones that are very much focused on things to be aware of when you're authoring assessment questions.
Yeah. Another question here. So one of those questions which you identified as having more successful for male students was one where you had to drop words into a sentence.
Yeah, that's right.
So related to that, I guess, Martin Greenhow asks, is there any gender difference with certainty-based questions where you can ask for an answer, then ask how certain they are in their answer? Is that something
that's an interesting piece of work? Martin, can I remember the reference? I'll look at it in the box. I haven't personally, but I'm aware that somebody else has done some work in that area, and it actually the answer to it relates to what the hypothesis is, that why there may be a multiple choice difference, and this is very, very stylized, and it's very much this, an archetypal, so I'm being a little bit careful as I say it, but it's the idea that I as a woman I'm less willing to guess, and so it's putting that there. So that's the sort of basis of the question, I think, and it's a really good question. I will find the reference and put it on the website.
That's great. Thank you very much, Sally. I can see in the chat already that your talk is having an impact. They're talking about how this needs to be included in the research agenda discussions that were going on earlier today.
I tried to put it there. I apologise. I wasn't able to get to the discussion at lunchtime. I'm just very much diving in and out of this conference, but yes, I think it's really important. Thank you.
Great. Thank you very much, Sally. That was great. Okay, so we're going to move on to our final talk of this afternoon's session. So this is pre-record with Colin MacDonald and Andrew Reknitzer.
Hello. Thank you very much for coming to my talk, and thank you very much to the organisers of EAMS 2020 for allowing me to speak on some stuff that we've been working on. So this is work together with my colleague Colin MacDonald. We're both at the Department of Mathematics at UBC. I'm going to talk to you about what we call paperless open marking, or PLOM, and you can find more information about our system at plomgrading.org and our repository at the link there. So what is PLOM? Well, let me give you the elevator pitch. It's kind of a tall building, but we'll get there. So let me start off by setting the scene. So a little while ago, I had to give a single midterm test in one of our very big first year calculus classes, which involved 1,250 students in 8 different time slots, so from Thursday morning through to Friday afternoon. All of those classrooms were very crowded, and we ended up giving 6 versions of this test, and we worked out that this was about 8,000 sheets of paper that we had to wrangle in order to get the whole process done. And needless to say, this was a very big project, and it ended up taking about 4 weeks from starting to plan the midterm through to returning the midterm to those students. And it became very clear that we need tools that are going to help us simplify the logistics of this whole process, not just to make the marking quicker, because we don't just want to write 2 out of 5 and go through. We want to give better feedback to the students, and at the same time we really want to be able to conserve instructor time, energy and sanity. And if you think about this sounds sort of like an impossible ask to get a tool that's going to do all these things without costing a lot of money. And so we started building something ourselves, and that we call PLOM, paperless open marking, and we try to make it completely free software. So in this way, PLOM is Libre, in the sense free in Libre, namely it's open source and built completely from free open source software components, so everything is pip or app or deb package installable. It's completely free in the sense that you don't have to pay any money. There are no fees or anything like that. Everything is AGPL3, you can download it yourself and run it yourself, and all of your data is secure. All the information stays on the server of your choice. You can download and install it wherever you want. So what does it do? Well, PLOM allows you to write tests on paper. So students write on bits of paper like these, with pencil, pen, whatever. And this is a very typical, very short test out of PLOM. You can see there's an ID page, it's the very first page there. Question 1 is a single page, and then question 2 are the 2 pages there. Now, if you look very carefully, however, you'll notice that the page 2 there is actually version B of that question, and question 2 is version A of that question. So what Plum is doing is it's interleaving the different questions in the test to help reduce the number of versions you have to make overall. So in particular, if you had 3 variants of a 4-question test, then Plum would actually create for you 3 to the 4, namely 81 different versions by picking one of those question 1s, one of those question 2s, one of those question 3s, and so forth, to make a test for each student. Okay, so it helps reduce the number of versions you need, and hopefully also reduce the leakage that might occur across giving a test across different time slots. Then you have to scan everything in, but that's the last time you have to handle the paper. Once everything's scanned into the computer, the marker can use a client like this, and a student who's working with us, Victoria Schuster, is going to give a little video demonstration of it shortly. They can mark on this client. This client's been very heavily optimized to make leaving feedback very quick and to make going through these papers quite quick. So in particular, a marker is only assigned to a single question or a single version of a single question, and it's blind marking. While they can look at different pages of the test, they're going to focus on the pages that correspond to the question, and they can never see ID pages. They can't tell whose test they're actually grading. And Victoria will give a good demonstration of this client near the end of the video and a bit more explanation of what it can do. Then once all the marking is done, Plum will automatically generate a web page for you that you can upload to a web server where students can collect their tests. And so again, the data doesn't go off to any third party, it's generated on your server and you upload it to your web server. And then in order for students to get their tests back, all they need to do is enter their student number and an exam code. So you'll have to upload that exam code to your LMS, but that's really the only LMS interaction you have to do. Student wants their test back, copy that from the LMS, paste it in here along with their student number, click, they get the PDF of their reassembled test. So at this point, what I want to do, I think at the end of my pitch as to what Plum can do, I wanted to say, please come and join us. We're in the process of building the system. We do have a functional prototype, which has already been used in about 20 courses to mark by about 60 faculty and markers to mark about 20,000 tests. We're in the process of building more documentation and more demonstrations of what it can do, how to use it. But what we're looking for now is really we want more people to come, test it out, use it, give us feedback, give us ideas, and join our community. Want to become a code developer? That would be fantastic. So we're really looking to try to build a community around this piece of software, which, as I'm sure some of you who have worked on big open source projects know, it's really an important part of this process. And so before I hand over to Victoria and then on to my colleague Colin, I'd like to thank some people, so namely a bunch of students, Elvis, Victoria, Vala, Dryden and Michael, who have made contributions to the code, been very, very helpful having them along. A bunch of faculty members who have reported bugs and given us ideas and given us feedback, really trying to make this product good. And I'd like to thank UBC Centre for Teaching, Learning and Technology, who have given us some funding, and the testers of the early prototypes. They gave us a lot of great feedback which helped make this possible. And now I'm going to hand over to Victoria, who's going to give a demonstration of the client, and then on to my colleague Colin, who will talk a little bit about installation. Thank you.
Plum is a free digital platform that allows for paperless grading of student work, while maintaining the security and privacy of classroom data. Simply enter your username and password and you can begin marking. This is our grading interface. We'll start by adding rubric elements, which consist of mark assignments and text or LaTeX to help us mark fairly and efficiently while providing useful feedback. Plum allows you to navigate our tool buttons using keyboard shortcuts, so you can keep one hand on your keyboard and one hand on the mouse at all times. This allows you to quickly change gears when you realize that student number 2 forgot to change their sign when differentiating a negative exponent. And perhaps the best part, while you're grading question 1, your TA can begin grading question 2, so you can work seamlessly and efficiently without having to exchange large stacks of paper. With Plum, you can zoom in and out as needed to help you evaluate hard-to-read writing so you can give accurate marks. Need to write a complex equation? Plum supports LaTeX in our annotations. And here you have yourself and your two TAs working seamlessly so you can return student feedback while it's still relevant. As you can see in the top left, Plum also supports image annotations in case an answer could be better explained using a graphic, or if you feel like adding a smiley face or good job sticker to your students' work. And there you have it. Your exam grading is complete, all thanks to Plum.
Okay, so you've seen the video and perhaps you'd like to try this software for yourself. So I'm going to talk briefly about how to install it. If you just want to try the Plum client like you saw in the video, then we can host a server for you. Just get in touch via email, and you will need to download the client itself, which should be available at plumgrading.org for Mac, Windows, and Linux. If, on the other hand, you want to dig in and get your hands dirty, then you can install the full software, including the server, on your own machine. So we support Linux. You'll need to download a bunch of dependencies and then use pip to install Plum itself. Alternatively, you can use Docker. After the server is installed, it includes a built-in demo. So that's the easiest way to get started. You make a new directory, change into that directory, and run the plum demo command. So what this does is it prepares a bunch of blank exams and then simulates student input by scribbling randomly on those papers. It then uploads all that data to the server, and you're ready to go. So run the client either on the same machine by typing plum client, or perhaps using a client that you've downloaded onto a different laptop. We're the Plum developers. Thanks very much for watching, and if you have any questions or you'd like to try this software, please get in touch at plumgrading.org. Thank you.
Okay, so I think Andrew and Colin join us. Are you available? Unmute you.
Hello.
Hi, Andrew.
Hi.
Hi. Okay, thank you for that. So participants, if you'd like to send some questions through to the Moodle site. Big question for you. So I think towards the start there, you mentioned that you gave out these questions sheets to students, you gathered them back in, I think you said you scanned them.
Yep.
With regards to everything that's been going on recently, did you have the opportunity to use this during the pandemic, and does it have that facility for students to do the scanning themselves and pass that on to the system?
So we didn't have a chance to do this during pandemic. I think Colin and I were both out of the country and on sabbatical in theory at the time. But it's something that we've been working on heavily since about December, is trying to get, or no, later than that, since probably February, March, is to get that facility to handle student uploaded materials. Because one of the very big differences there is that while you might ask your students to carefully upload question 1 here, question 2 there, question 3 there, they might not do that. So you have to handle very unstructured inputs from your students and be able to juggle those around and so forth. So that's taking quite a bit of work under the hood, as it were, to change how the system works. It's also going to require some LMS hackery in order to be able to get stuff out of the LMS. So the system doesn't have a capacity for students to upload directly into that. I don't want to write my own LMS, essentially. So we would need to be able to extract it from Canvas or something similar. Yeah,
okay, that's good. So I guess so earlier in the conference we had a talk from the guys at Edinburgh, who are very organised about what they do with their submitted work. But for us at Newcastle and probably other places as well, teachers were left to their own devices really to do their annotation using whatever they felt as though they wanted to use. So I guess linked to that question from James Fody, is there an option to use Plum just as an annotation software, sort of standalone without any interaction with servers?
I think we could probably do that. I mean, the source code is all there. The client, it probably isn't terribly difficult for us to hack, for want of a better term, or to manipulate the client so that that would be an option, so that you could just, instead of get next, it was, you know, give me the next file in this directory. So that's a possibility. And indeed, these are the sorts of ideas that we're really interested in. That the complication there might be that you would need to have files named in some sensible way so that the system could not just annotate things, but to make sensible recordings of, oh, this is student 7 question 1, and fill in a spreadsheet for you. So you don't have to go back and view the annotations and make notations in your spreadsheet by hand. But those things are all possible. I mean, I think once you have your hands on the student input and you have that on your own machine instead of off at some third party, a lot of things are possible. It comes down to quite how you get that stuff from students, what you do with those files and so forth. But this is possible, and we have this annotation engine. It can be separated from the server in some reasonably sensible way. So it's a good idea, and indeed, we should put that on our to-do list. So thank you to the person who suggested that. So, and I mean, Colin, do you have something to add to that?
No, not really, other than there's some people interested in, or at least we've sort of talked about the possibility of connecting it to different systems rather than our own server. And Submiti was the one that sort of came up in conversation, but haven't done anything about it yet. Need help.
Thanks both. I think we're going to be extending your to-do list here. So so one of the other things, like I guess we got used to in lockdown, a lot of us got used to annotating on a tablet. That was new to a lot of people. Is that something that is supported? Questions from George Kinnear. Is it possible to use this on, for example, an iPad?
So
maybe
I'll let Colin go here.
I would no to the iPad thing, not yet. Because we don't have an easy way to compile for that yet. Maybe Andrew could say more about that, but I have tried it on a tablet, but not an Apple tablet. And it's doable, but it's not optimized for tablet use yet. So a simple example is you'd like to be able to use your finger to move the paper around and your pen to write. And right now the pen and the finger generate the same input. So, you know, if someone were passionate about that, I suspect a little bit of work would make it quite usable on a tablet, but we're not quite there yet.
I also have a maybe not pedagogical reason why I wouldn't recommend using it on a tablet, and that's because, so in the UBC context, or in our mathematics department's context, we tend to have these ludicrously large, 1,000-person calculus classes, which are marked by a team of 20 or 30 people, and many of those people don't have terribly good handwriting, to be blunt. And so we've really, Colin, so we really encourage this comment reuse system. So in the video demonstration you saw there's a bunch of comments, standard sort of comments down on the left-hand side, which you have a bit of text, but you also have a delta mark. And so by pasting one of those comments in, you have a very standard, not the chain rule -2, or revise the chain rule -1, that sort of comment where it would be a standard bit of text which should be legible and a standard mark that goes with it. So we're sort of discouraging we want to discourage our TAs from making too many comments on the fly, but instead trying to reuse standard comments. And if they do find that, hey, I've said not the chain rule 7 times so far, I should make that a standard comment, so that later on it becomes very quick to do that. And it's just more consistent across that 1,000 papers. But
and that
can
part
you get it
does
working
work
on
fine
tablets so
on
you can circle things and things like that? That should not be so difficult. But the text entry is important in this context, just because of handwriting. There's even very silly things like if we have TAs that are from North America, they write a 1 just as a simple stroke down, and we have TAs from France who might write they write something that looks a little bit like a 7, and some of our students don't recognize that this is a cultural difference, and so even very simple things like that do come into play. So
Well, thank you, Colin. Thank you, Andrew, and thank you to our earlier speakers, Sally and Agnieszka. So that's all for today. I'll just bring up the program for tomorrow. I'll find it. Here we go. Okay, so we're back tomorrow morning, 9 o'clock British summertime, with some more lightning talks, a couple on Stack and one from a project in Germany, building web-based course materials for engineering students. So we look forward to seeing you then. Thanks, everyone.
Chris, can I just, oh, people are going. I just wanted to plug the main discussion area again, which we haven't talked about recently. There are some discussions going on there about using e-assessment, when it goes wrong, when it goes right, that kind of thing.
Thanks,
That's
Chris.
it.
Thank you. Bye, everyone.